All right. Okay. Today we're gonna be doing some balancing chemical equations. This is for Ken's chemistry. So before we get started, make sure you got page 16 open in your packets. We're gonna be going through most of the first part, not every single question, but most of them. Um, and for this, I would recommend you also have a whiteboard or a separate piece of paper you can write on, because there's not really a lot of room on here to draw all the charts we need. Okay, so with that, hold on. Yeah, we're gonna go with purple. Okay, so we're gonna start with number one. So it's saying blank sodium plus blank O2 makes Na2O2. Okay. Um, some of these you may be able to like just look at and figure out. Um, for all of these, I'm just gonna go through and make a chart. So we got this. I'm gonna draw a line down there. We want to separate both sides. We're gonna have NAs, one element, and O's for our other. So the only two we have here. Oh wait, this is supposed to be Na2. There's gonna be a lot of mistakes like that. Okay, so on this side of our equation, we have one sodium and we have an O2, which means there's two oxygen atoms. So we got two of those. Over here, it's very poorly drawn, but we have two sodium and again, two oxygen because of that O2. So when we're balancing like this, we want to have the same amount of things on the same side or on either side. So right now, our O's are good. We have two on our left side and two on our right side. That's good. Our sodiums are not. We have one on this side, two on this side. So when we have things like this, we want to fix the side that has less. So in this case, that's our left side. When it comes to balancing equations, we can't change these little numbers in front at all. All we can do is add big numbers behind them. So in this case, oh, and also remember, if there's no number there, we're just counting this as 1 right now. So right now there's a 1 there. It's just not written. So we'll bump that up to a 2. And then we'll have 2 sodium on this side, 2 on this side. Everything's good to go. So our final thing will be this. We'll have a 1 in front of here. All right. Yeah, so that's number 1. Just going to erase all this. And we'll go on to number 2. Yeah, we're going to go through the first 5 here and then a couple of other ones throughout. So number 2 is blank H2 plus blank O2 makes blank H2O. All right, so then we'll get our chart set up. In this one, we only have H's and O's. So we'll put H here, O here. All right. So on our left side here, we have an H2. So we'll have 2 H's, and O2. We'll have 2 O's. And on this side, we have H2O. Another way we could write this is H2O1. There's a 1, we usually don't write that. So on this side, we'll have 2 H's and we'll have 1 O. Now, if you'll notice, not everything matches up. Our H's are good right now, but our O's are not. So again, we want to start with the side that's lower. This side has less O's. Since there's only one chemical, there's only one thing we can do. We'll bump that up to a 2. And this is going to change both our H's and our O's because we're adding another H2O. And this is sort of saying, like we started with 1 H2O, putting that 2 in front means we add another H2O altogether. So we can either count it this way or we can kind of like multiply them out. So for H's, 2 times 2 gives us 4. And for O's, 2 times 1 gives us 2. Now, you'll notice not everything is good to go here. I meant to erase all that. Okay. Now that we've adjusted this, we upset our h's again. So now we have 2 on this side. Need to fix this side. Only one thing we can do to add more h's. So let's try bumping that up to a 2. It's going to get us to 4. And then we're good to go. So our final answer will be 2H2 plus 1O2 makes 2H2O. And that is number 2. Just going to erase all this, and then we'll move on to number 3. So number 3 is saying, ooh, this is a weird one, blank Na plus blank NaNO3, right? Yes. Okay, not going crazy. Makes blank Na2O plus blank N2. Okay, we got a little more going on here, but let's see. Let's figure out what kind of elements we have on either side. If we have NAs showing up in different places, that's all good. We still just have NAs. We have N's. And we have O's. And that's true for both sides. Should always be true. Right. So now, counting our elements. If we see, when we're counting elements, we're counting how many total on either side. So we can see we have 1 Na here and 1 Na here. So that's going to give us 2 in total. Now for N's on this side, it can be kind of funky when we see like something smashed in the middle here. But remember, we can also write that as Na1, N1, O3. So we'll just have 1 N on this side. And now for O's on this side, we got that little 3 in front, so that's going to be 3 O's. That's a fun 3. Okay, for NA's on this side, it only shows up in one spot, so we got NA with that little 2 in front, got 2's, or 2. For N's on this side, we have N2 over here. So we got 2 N's. And for O's, you can just write that as O1, 2. So we'll just have 1 O on this side. Now, you'll notice probably pretty quickly, not all this stuff matches up. So, our N's don't match up and our O's don't match up. Now, from here, you can either start with N's or O's, fixing those. In this case, I'm going to start with N's. So, our N on our left side is lower. So, we got to figure out how we can add more N's. Adding another just Na, that won't do anything. This is the only thing that has N's in it. And we want 1 more N in total. There's 1 in each of these, so we'll bump that up to a 2. Now that is going to change everything else we have on this side, but that's okay. So now, NAs, we have 1 here, and then we have 2 times 1 here, so 1 plus 2 is 3 total. For N's, we have 2 times 1, that's just 2. And then for O's, we have 2 times 3 right here. So that's going to be 6 in total. All right, now you can see everything's kind of out of whack over here. That's okay. Let's start with O's over here now. We can start with NAs or O's. NAs are going to be kind of weird, but those should be easier to tweak. So we'll start with O's. We're at 1 right now because we only have 1 of these things, and we need 6 in total. There's only one way to add O's over here, and that's to add more of these things. So if we want 6 total, we need to know what times 1 is 6. In this case, it's going to be 6. So if we put a 6 there, we'll have 6 times 1 gives us a total of 6 O's. It's also going to mess with our NAs though. So we'll have 6 O's. And now for NAs on this side, we only have NAs right here. To figure that out, we would do 6 times 2 for each of these things. Because remember, this is saying we have 6 of these in total. Yeah, so that'll give us 12 over here. Now, our N's are good, our O's are good, our NAs are not good. So, how do we fix that? Luckily, on this side, we have just this blank NA thing, so we can just add however many we need. Right now, so we know we need 12 in total right here. We're getting 2 from this other chemical right here. So that means we need 10 more from just this, which means we can just slap a 10 right there. And we have 10 here, 2 here. That gives us 12 in total. So this will be our final answer. 10 sodium plus 2 sodium nitrate gives us 6 sodium oxide and 1 nitrogen gas. You don't need to know that in words, just, yeah. Okay, sweet, that was number 3. Some of these there's going to be a lot of steps to, and it might seem like we're going backwards by adding more of one thing, but we'll get there eventually. As long as you fix something that's lower, you'll get there. Okay, number 4. Ooh, this one's weird. So blank carbon plus blank S8 gives us blank CS2. Okay, so we'll get our chart set up. This one's pretty straightforward. We only got C's. Oh, that's a big C, and S's. Okay, so on this side, it's got 1 C, and we have an S8, so that's 8 S's. On this side, we pretty much have C1, S2, so 1 C and 2 S's. So right now, our C's are good, our S's are not. This side is lower, so we'll want to fix our S's on the right side. We want 8 in total, and we have 2 in every one of these. So we want to figure out what we need to multiply by 2 to get to 8. Give you a second to think about that. You can pause the video if you want. In this case, we're going to need 4 of these. And because this is CS2, we're going to be changing both our C's and our S's. So, for S's, we know 4 times 2 is 8. And for C's, 4 times 1 is 4. Alright, now our S's are good, our C's are not. But luckily, we have just C by itself, so we can add however many we need. Remember, this is C1, and we want to figure out what times 1 gets us to 4, because we need 4 total. So, in this case, we're just going to need to slap a 4 there. Just because 4 times 1 gets us to 4, and then we're good to go. So our final answer, I kind of forgot to mention this earlier. You've seen me do it, but if you have a blank, I would write a 1 in. I don't think you need to, but I would. Yeah. So, in this case, 4 carbon plus 1 S8 gives us 4 carbon disulfide. Yeah, okay, that is right. Oh, whoops. Hit the wrong thing. Okay. On to number 5. So, blank K plus blank B2O3, right? Yep. Gives us blank K2O, 2O plus blank B. Okay, this looks like a lot of weird stuff going on. I don't think this one will be that bad. So, get our chart set up. can see we got K's, B's, and O's. So we got K, B, and O. Oh, okay. So on this side, this one's pretty straightforward. We only got one K by itself over there. Got B2, so we got two B's, and O3, so three O's. On this side, see we got K2, so that's two K's. Remember that would be like O1, so we'll have one O and just one B right now. All right. So this we could start with any of these because none of them match up. And remember, no matter which one you start with, you'll eventually get there. I'm going to start with O's because I think that will give us the fewest steps. So O's on this side. We have one right now. We need three total. There's only one way to add O's, because adding just B's won't do anything. So we'll need to add more of these. In this case, we need to figure out what times 1 gets us to 3. Give you a second to think about that. In this case, it will be 3. So 3 times 1 will get us to 3. This will also change our K's, though. So now we'll have 3 times 2 K's, which will be 6 in total. All right. So now, there's a couple of things we need to tweak, but none of them are that bad. We need to change our B's and our K's. I'm going to go with B's first. Doesn't really matter what you do. Yeah, so we have 2 B's on this side, 1 on this side. So we need to fix our B's over here. Since we just have B by itself, remember that'd be B1. Yeah, we'll just slap a 2 there, because 2 times 1 would give us 2 in total. I'm just going to reset ahead of time. So 2. Now, we need to fix our K's over here. Right now we're just at 1. I just erased that, yeah, fewer clicks. But we need to figure out, so remember that's K1, what times 1 will get us to 6. In this case, that'll just be 6. So then, our K's match up, our B's match up, our O's match up. We're good. So, final answer. Oh, that really looks like a 1. Okay. So we'll have 6 potassium plus 1 diboron trioxide makes 3 potassium oxide and 2 boron. Yeah, that is number 5. Next, I'm going on to question 6. Okay. So this is going to be question 6. After this one, I'm not going to go in order anymore. There's just a couple more I'll cover. They should be some of the bigger, weirder ones, and the rest, I think you can use this video to solve. But, 6 is blank cesium, which is CS, plus blank N2 makes CS3N, blank CS3N. Okay, bam. So we've only got 2 elements here. We've got CS's and N's. So let's start with our counting. Over here, we have 1. On this side, we have 2. And then we'll move over to this side. We have CS3, so that's going to be 3 CS's. Remember, this would be like CS3N1, so we only have 1 N over here. All right, so now neither of these match up. We can start with any one of these. I'm going to start with N's. So let's see. Our N's are lower on this side. Since there's only one thing we can do to add more N's. We got to add more of these. So, what am I saying? Each of these has 1 ends. We need 2 in total, so we need to figure out what times 2, or what times 1 will get us to 2. In this case, that would be 2. Because 2 times 1, I need to erase CS's because we're going to add more of both. But 2 times 1 get us to 2 ends. Now for our CS's, since we had more of all of that, we're bumping these up. So 2 times 3 gets us to 6. All right, now our ends are good, our CS's are not. So we need to add more CS's on this side. Luckily, we have it just by itself. Remember, that's CS1. So we just need to figure out what times 1 gets us to 6. In this case, it'll just be 6. And we can plug in a 1 for that blank. So this will be our final answer. 6 cesium plus 1 nitrogen gas gets us 2 cesium nitride. Okay. All right. And remember, we are not going in order anymore. I think 7, 8, and 9 are pretty straightforward. A little playing around, but yeah, I think that's doable. And then we are gonna go on to 10. Right, this one's weird. Okay, so blank H3 PO4. I believe that's phosphoric acid. Plus blank magnesium hydroxide MgOH gives us, oh wow, that's a weird one. Okay, MgPO42, Mg3PO42, G3P, sorry, parentheses. Okay, hold on, gotta try that again. Mg3 parentheses PO4 2, and I believe hydrogen gas. Nope, H2O. Okay. Plus H2O. Okay. All right, this is a big one. So let's see. Let's look at our elements. We have H's. We know that. We have P's. Ooh, wow. Okay. We have O's. We have Mg's. Okay, so we have 4 different elements here. H, P, O, and yeah, we already got O's and H's, so good over there. We'll go here. Okay, now we'll just start off counting. Start with H3PO4. So, H3. Oh, we gotta count total on a side. Okay, so we have 3 H's right here, and then we have this OH2 over here. What this 2 is saying, it's not referring to the whole chemical. It's sort of like these little subscript things. But you can see we got the parentheses. This is for our polyatomic ions. We've sort of covered those. But basically, this OH is going to act as one thing, and this 2 applies to everything in the parentheses. Same with the PO4 over here. That 2 is going to apply to both of those. We'll get there in a minute. So we got 3 H's right here. And over here, we've got an OH with the 2 in front. So this 2 is going to kind of multiply each thing inside here. So we have 1 H there times our 2 gives us 2 H's total right here. So 3 plus 2 gives us 5 H's in total. Now P's on this side, pretty straightforward. We got PO4. Remember, that's like P1O4, so just 1. For O's, we're going to look at both of these again. So we got 4 right here, and then we've got 1 times 2 over here. So that's 2 plus 4 gives us 6. And then for MGs on this side, yep, I wrote that right. Okay, so remember that's like MG1, so we just got one MG over here. Now on this side, let's start with H's again. There's no H's in this first one, so we just got to worry about the H2O. I think okay, hold on. I'm going to erase that because that looks rough. All right. Plus blank H2O. Okay, also doesn't look great, but that's fine. So right now, we only got one H2O, so we got two H's. P's on this side. Remember that 2 outside the parentheses multiplies everything in the parentheses. So we have P1O4 times 2. 1P times 2 gives us 2 in total. Let's see. So we got that in both of these. We got 1 from the H2O, and then we have 4 times 2 over here. So that 4 times 2 is 8, plus 1 gives us 9. For MGs, we got MG3 right there. So that's going to be 3. So this one's kind of a mess. I think we could really pick anything to start with. I am going to pick MGs to start with. So let's see. We got 1 over here, 3 over here. This side's lower. Only one thing we can do to add more MGs is add more of these. We need, since there's 1 in each of these, and we need 3 total, we need to figure out what we're going to multiply by 1 to get to 3. In this case, it will be 3. So that 3 times 1 mg gets us up to 3 mgs. But because we have this OH, we are changing our H's and O's as well. So we'll start recounting our H's. We have 3 here, and then we've got 2 H's in each one of the MgOH's. So we got that 2 times that 3. That's going to be 6. So 6 here plus our 3 here, 9 total. And same thing for O's. We have 2 in each of the MgOH's. So 3 times 2 gives us 6 total in here, plus our 4 over here is 10. All right. Now you can see our MGs are good. Everything else is not. I think next I'm going to do P's on this side, because that's also a weird one that messes with a lot, so we're just going to get that out of the way. Yeah. What am I thinking? Okay, so we're at 1P right now. We need 2 total, because we got 2 on this side. There's 1 in each of these, so what times 1 will get us to 2? In this case, it will be 2. And this is also going to change our H's and O's again. I think in some of the future ones, I'll show you a different way we can think about this. I think just for now, recounting them all is a little simpler. So now 2 times 1P, we're at 2. Now let's recount our H's. Remember over here, 2 in each of the MgOH's times 3 gives us 6. So we're going to have 6 over here plus whatever we got over here. In this case, we got 2 times 3 is another 6. So 6 plus 6 is 12. We have 12 total. If this counting stuff isn't making sense, I wouldn't worry about it too much. We'll get a lot of practice with it. Yeah. Okay, now on to O's. Remember, we'll start with our MgOH's. There's 2 in each MgOH. So 3 times 2, because we have 3 MgOH's with 2 in each MgOH. 3 times 2 is 6 there. Then over here, we've got 2 times 4 is 8. So 8 plus 6 gives us 14. All right. Okay, that looks good for this side. Now there's quite a bit of stuff we need to do on this side. Well, not really. Our P's are good. Oh, boop, 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 boop. Okay, that looks good. Our P's are good, MG's are good. We just need to fix H's and O's. I want you to look on this side and figure out which one of these we're going to want to add more of if we want to add H's and O's. You can pause for a second. All right, so if we want to add H's and O's, we're going to want to add more H2O's because all that has is H's and O's. When we're looking at this, I think I'm going to start by fixing our H's first. So we're going to forget about that too. Remember, in each H2O, there's 2 H's. And we want 12 total. So what are we going to multiply by 2 to get to 12? Give you a second to think about that. Okay. So in this case, we want to multiply by 6. Oh, that's also going to change our O's, so I'll erase that. All right. So now to recount our H's, there's nothing in here, so we're just worried about the H2O's. So 6 times 2 gives us 12. Pretty straightforward. Now for our O's, it's a little bit more. I just thought of a better way I could do this. So if we look at our MGPO4s, remember that parenthesis multiplies everything inside of it. Right now we've only got one of these, so we don't need to worry about all that other multiplication. We can just do our 2 times our 4 there. So we'll have 8 O's from that, so 8. And then in our H2O's, remember that's like H2O1, we have 6 of them, so 6 times 1 gives us 6. So we have 8 plus 6 equals, that'll be 14 total. Nice. Okay, now if you look, it looks like everything matches up, so we should be good to go. Plug in a 1 to that blank. Yeah, that should be our answer. It's 3 phosphoric acid plus 3 magnesium hydroxide makes 1 magnesium phosphate and 6 water. Woo. Yeah. So the reason I'm not going in order anymore is because this would be a super long video if I went through all 20. We don't need to do that. So let me just fix that. Okay. This is number 11. So we have NaOH plus H2CO3 makes Na2. Aha. Okay, just went through this whole thing. Gonna edit that part out, but I just made a whole huge mistake. Yeah. So now, take it from the top. We have, let's count our atoms. So we have one Na1 over here, just one Na. We have O's in both spots, so we have 1 plus 3 is 4. And then we've only got 1 H here, 2 H's here, that's 3 total. And we've only got C in one spot over here, just got 1 C. Now let's count our atoms over here. Start with Na's. We have Na2. I didn't add that the last time I did it, and that made this whole thing a mess. So we've got 2 Na's over here. For O's, we've got 3 here, 1 there. That's 4 total. For H's, only have those in one spot. We have H2, which gives us 2. And C's, we just got 1. Okay, this looks much better. Now you may be noticing our Na's don't match up and our H's don't match up. To kind of fix this, I'm going to start with Na's. So let's see, we're at 1 right now. Let's bump that up to 2. It's going to change our Na's, our O's, and our H's. All right. So we have 1 Na in each of these. We have 2 of them, so 2 times 1 gives us 2. Same thing for O's, but we got those in both spots. So let's see. 2 times 1 is 2, plus the 3 over here is 5. And same thing with the h's. 2 times 1 is 2, plus 2 right here is 4. All right, now let's see. Our O's don't match up and our H's don't match up. We need a way to add one more O and 2 more H's on this side. I'd like you to pause for a second and figure out which of our 2 chemicals we're going to add another one of. Okay, so in this case, there's only one that has both H's and O's. That's H2O. So let's try bumping that up to a 2. It's going to change our H's and our O's on this side. There we go. Okay, let's count our O's first. We have 2 times 1 from our H2O's, that's 2, plus our 3 right here gives us 5. And our H's only show up in one spot. 2 times 2 gives us 4. All right, so our final answer is this. Awesome. Okay, I just wasted a whole lot of time doing that wrong. All right. Okay. All right, that was number 11 eventually. All right, now on to 14. Ooh, this is a weird one. All right, H3PO4 plus blank. Make sure I write this right. KOH, potassium hydroxide, makes blank K3PO4, right? Yeah. PO4. I was just making sure I got my numbers right. I don't want to make another super long mistake again. Okay. H2. Oh, yikes. Let's see. Oh, look at that. Just discovered the back arrow. We're going to be using that a lot. Okay. All right. Set up our chart. See what elements we have. We have H's. We have P's. We have O's. And we have K's. So get our lines in. All right, perfectly parallel lines. All right, now let's count our atoms. On this side, H's show up in both of these. So we've got 3 here and 1 here. That's 4. We only have P's in one of these. Remember that'd be like P1O4. So we got 1 P. I'm gonna just fix that line. There we go. Okay, 1 P. O's show up in both. We've got 4 here, 1 here. That's 5. And K's only over here. Just got 1 of those. Right, now on this side, H's only show up on 1. We got 2. P's only show up here. We got 1. O's show up in both. We've got 4 here, 1 here. That's 5. And K's, got 3 of them there. All right, so our H's don't match up, and our K's. Oh, why did I write a K there? Oh my gosh. Okay. We got 3 K's. Okay. So let's see. We can fix either H's or K's first. I'm gonna start with K's. So let's see. If we go to this side, there's only one way to add K's. We can only add more KOH's. We need 3 total. There's 1 in every KOH. So we need to figure out what we need to multiply by 1 to get to 3. In this case, oh boy, okay, that'll be 3. Nice. So that's going to change our K's, our O's, and our H's over here. So our K's, 3 times 1, that just gives us 3. Our O's, we have 3 times 1 over here, so that's 3, plus our 4 there is 7. Now our h's, we've got 3 times 1 right there, which is 3, plus our 3 over here, that gives us 6. I thought that was 9. Okay, it's been a day. All right, now our h's don't match up, and our o's don't match up. We need a way to add 4 more h's and 2 more o's. So, let's see. If we need to add h's and o's, we're probably not going to want to add KEPO4. That doesn't even have an H in it, and that's a lot of stuff. Probably going to want to add H2O's because that has H's and O's. Now, one thing you might notice, if we need to add 4 H's and 2 O's, you might notice that we have 2 H's for every 1 O that we need to add. And luckily, H2O, every one we add has 2 H's and 1 O. So, let's start with our H's. That point will make more sense in just a second. All right. So, for our H's, we need 6 total. We only have H's in our H2O's. So what times 2 do we need to get to 6? In this case, that will be 3. That'll get us to 6 H's. Now we need to count our O's. Start with our H2O's. We have 3 times 1 is 3, plus our 4, which is 7. And since everything matches up, we're good to go. Put 1s in our blank spots. That'll be our answer. Awesome. All right. All right. Okay, next one. See, we're going to go to 16. 16. All right. We have blank RB plus blank RB N O 3 gives us blank RB 2 O, that's a bad B, but whatever, plus N2. Okay, let me make sure that's right. RB, RBNO3, RB2, ON2. Okay, sweet, that looks good. So, look at our elements. We got RBs. We got N's. And we got O's. Alright, those kind of suck. Alright, there we go. Anyways, okay, let's count our atoms. Got 1 RB here, got 1 RB here. So that gives us 2 RBs total. Our N's on this side, only right there. Remember, that'd be like N1O3. So we just got 1 N. O's only show up right there. We got O3. So 3 O's. All right. On this side, we got RB2. So 2 RBs. Our N's, we have N2, so that's 2. And then O1 pretty much, so that's just 1. So N's and our O's don't match up. I kind of want to start with our O's over here. I think we could do either, but well, I mean, I know we could do either, but I'm going to start with our O's. So we got 1 here. We need to get to 3. If we look at this side, adding N2s won't do anything to our O's, so we need to add RB2Os. So that'll change both our RBs and our O's, which is why I erase those. So if we're worried about our O's, let's see, there's 1 in every one of these. We need to figure out what we need to multiply by 1 to get to 3. In this case, it will be 3. 3 times 1 gives us 3 O's. Now that also changes our RBs. So we have 3 times 2 over here, which gives us 6 total. Now, you may notice that both our N's and our RBs don't add up. I'm going to fix our N's next. The reason I'm not fixing RBs is because on this side, there's 2 ways we can add RBs. One of these messes with the rest of the stuff. The other one doesn't, and I don't know exactly which one we'd need to add. So I'm going to start with N's. Only one way to add N's over here, and we want to get it up to 2. We need to figure out what we need to multiply by 1 to get to 2. It's going to be 2. But that one's going to change all of these because we have RBs, N's, and O's. So let's count our RBs again. We got 1 here, and then 2 times 1 right here. So that's 2 plus 1, which is 3. For N's, we only see them right here. We got 2 times 1, that's 2. Now our O's, this kind of throws everything in a loop. We got 2 times 3. It's going to be 6. Sweet. So now we notice RBs and O's don't match up. Before we fix RBs again, we're going to worry about O's on this side. Because remember, if we add O's on here, that also adds RBs, and then we need to fix that again. So we're going to do O's first. Let's see, we're just going to take it from the top. Alright, so we need 6 O's total. And we have 1 O in every one of these. So we need to figure out what we need to multiply by 1 to get to 6. In this case, that'll be 6. Because 6 times 1 O gives us 6 O's. Alright, and then that also changes our RBs on this side. So now we have 6 times 2, which is 12 total. Alright, now our N's are good, our O's are good, our RBs are not good. But what's nice about this is we have this single RB over here that doesn't mess with the rest of these. So, we just need to figure out how many of these we need to add. So we need to get to 12, and right now, well actually, okay, hold up. Okay, so we're just going to discount this one quick. We need to get to 12, and so far we've got 2. So we need to figure out what we need to add, which I'm going to put as X, to get to 12. In this case, we would need to add 10 more things, 10 more RBs to get to 12. So that means we can kind of just slap 10 in front right there. And then if we recount, we have 10 RBs here, 2 RBs here, so that's 12 total. That is going to be our answer. Put that 1 in the blank there. Yeah, that's 16. Right, next we're going on to 17. There's got to be a quicker way to erase this. I just don't know it. Alright, so 17. 17. Okay. Ooh. C6. Okay, that's not a C. C6 H6 blank plus blank O2. Yep. We'll probably talk about types of reactions later on. This will be a combustion reaction. Makes CO2 and H2O. You don't need to worry about this being combustion or not, but fun fact, I guess. Okay. So when it comes to combustion reactions, there is a formula to just figure this out, but I think it's a little simpler to just, yeah, just do it. So let's figure out what kind of atoms we got here. We got C's, we got H's, and we got O's. All right. Sweet. So let's count our stuff on this side first. We got 6 C's. We got 6 H's too. And we got an O2. That's just 2. On this side, looks like we only got 1 C over here right now. For H's, only right here. We got H2. That's 2. And then O's, let's see how many we got. We got 2 here, 1 here, that's 3. Alright, you may be noticing our C's don't match up, H's don't match up, and O's don't match up. I'm going to give you a little tip. If you don't remember this, that's fine. When it comes to combustion reactions, if the O on this side is lower, we're going to do that last, because we can just add a lot of these all at once, but that's not important right now. So basically what I'm saying is we're going to fix C's and H's first. Let's start with the H's. Those are pretty straightforward. So if we get rid of that, it's going to change our H's and our O's. That kind of gave it away. But we're going to be adding H2O's because that's the only thing on this side with H's. So we're going to add more of that. In this case, we want 6 total, and there's 2 in every H2O. So what times 2 is going to get us to 6? In this case, that'll be 3. So 3 times 2 times 2 H's gives us 6 H's. And now let's count our O's. Start with our H2O's. We have 3 times 1, which is 3, plus our 2 over here is 5. Awesome. Okay, now we need to fix our C's. All right. So we need 6 C's over here total. There's 1 in every CO2. Yeah, so what times 1 gets us to 6? In this case, that's going to be 6. That's also going to change our O's too. So let's see. 6 times 1, that gets us to 6 C's. Now for our O's. We've got 3 times 1 over here. Oh, we're going to need to change some stuff in a second. That's going to be 3 plus our 6 times 2, which is 12. So 12 plus 3 is 15. Now, only thing that doesn't match up is our O's. But we're not going to mess with those right now. And here's why. Maybe noticing we have 2 O's, which is an even number. And we have 15 O's over here, which is odd. The only way to add O's on this side is to add them in increments of 2. If we add 2's to an even number, it will never be odd. So, weirdly enough, we're going to need to add more C6 H6's. We're going to add another one of those. And that's going to double, what the, okay. Yeah, that's going to double both our C's and our H's. So 2 times 6 is 12. 2 times 6 again is also 12. If that even an odd explanation didn't make sense, basically, if we, let's say we add 6 O's over here, that's going to get us, or actually let's go 7 first. That's going to get us up to 14 O's over here. If we bump that up to 8 O's, or 8, that's going to get us 16 over here, which just jumps right over 15, and there's nothing we can do about that. So that's why we're adding more of these. Okay. So now we need to fix our C's and H's again. We're just going to take it from the top with, well, okay, hold up. I'm getting ahead of myself. Let's start with our C's. Okay, so again, there's 1 C in each of these, and we need 12 total. So what times 1 gets us to 12? In this case, that will be 12. We'll be at 12 C's. This was at 3. So now we need to recount our O's. All right, well, let's start with our CO2s. That is 12 times 2, which is 24. So we got 24 there, plus 3 times 1, is 3. That gets us to 27 O's over here. Oh, okay. 27. All right, now our H's don't match up. So we need to fix these. Again, we want 12 total. So we need to figure out what times 2 gets us to 12. Luckily, we kind of have that backwards over here. We're going to put in 6. It's also going to change our O's again. So 6 times 2 for our H's gets us to 12. For our O's, again, we have 24 over here, plus, and then we just change this amount. 6 times 1 is 6, which gives us 30 total. Awesome. Okay, now the only thing that doesn't match up is H's, or O's, my bad. H's are good, so are C's. O's are not. So, we need to add a lot more O's. Luckily this time, both of them are even. We can figure that out. Since this is the only way to add O's over here, so we just need to figure out what times 2 is going to get us to 30. If you can't do that in your head, that's fine. You can take out a little calculator. Just do 30 divided by 2. See what your answer is. If you want to do that, I'd pause the video for a second. Okay, and then once you got your answer, if you plug that into a calculator, should be 15. Because 15 times 2 gets us to 30. And that's 17. Yeah, real exciting. Yeah, okay. Okay, on to the next one. I think there's only, 2 more we're going to be covering. We're going to cover 19 and 20. Is, oh, yeah, okay, I see why I picked this one. AL parentheses OH close parentheses 3 plus blank H2CO3 CO3 makes blank AL2, oh geez, okay, parentheses CO3 3 plus H2O blank. Yikes. Okay, this is a lot, but that's okay. We can handle it. I can draw a straight line, I promise. Okay, so now let's figure out what elements we got. We got ALs. We got C's. We got O's. And we got H's. Went a little out of order there, because I think this is going to make it a little easier to, like, follow as we go along. All right, putting our lines there. Awesome. Okay, now let's count how many we got. Over here, AL only shows up in one spot. We got 1. C only shows up in one spot. We got 1. O's show up in both. Remember the parenthesis, or the number outside the parentheses multiplies the stuff inside. So we've got O1, H1 on the inside. 1 times that 3. There's going to be 3. Hold on. So we got 3 here, plus that 3 right there. It's going to be 6. And same thing for the H's. 3 times 1 is 3, plus that 2 is 5. Awesome. And then over here, ALs only show up in one spot. We got AL2, so that's 2. C's, remember the number inside the parentheses multiplies everything inside. So we got C1 times 3 is 3. Then we got O's. A lot going on here. Remember that multiplies inside there, so 3 times 3 is 9, plus this 1 is 10. And then for H's, we've only got them right here. We only got one H2O, so that's 2. All right, nothing matches up here. Since a lot of things contain H's and O's, we're going to worry about AL's and C's first. I think let's start with AL's. There's only one way to add them on this side, which is the lower side. Let's bump that up to 2. Okay. Yeah. So that's going to change AL's, O's, and H's. Nice. So 2 times 1 AL is 2. My voice is kind of getting shot. All right. And then for O's, we want to figure out how many we have in one of these and then multiply it by 2. So in one of these, we have 3 times 1, which is 3. Times that 2 is 6. So we have 6 O's from our ALOHs. Plus this 3 over here is going to give us 9. All right, and then H's, same thing. We have 3 in one of these, because 3 times 1. And we have 2 of them. So that's 6 altogether, plus that 2 right there is 8. All right, that's a pretty solid start. Now we're going to fix C's. So we need 3 C's on this side. So we got 3 over here. We'll erase that. Right. There's 1 C in each of these things. So to get to 3, we're going to need 3. That will also change our H's and our O's. Lovely. All right. So now let's start with C's. We got 1 C in each. So 1 times 3 gives us 3. We got 3 O's in each of these. Times 3 is 9. And if you remember, we had 6 from that total. So 9 plus 6 is 15. Remember, we had 6 H's over here. Plus 3 times 2 is 6. So 6 plus 6 is 12 total. Awesome. Okay, I think this should work out pretty well. All right, we need 10 more H's, and we need 5 more O's. If you notice, we have double the amount of H's we need to the amount of O's. Luckily, that works out. So, if we discount our H2O, we would have 9 O's over here, and we would have 0 H's if we don't count this. Oh, hold on. Okay, that's a useless point. Never mind. Okay, we're just going to worry about our H's first. H's only show up right here. So if we want 12 H's, we need to figure out what multiplies by 2 to get to 12. In this case, it's going to be 6. So we'd get up to 12 H's. Now we need to count our O's. Remember that 3 outside the parentheses multiplies that O3 inside. So that's 9 from this, plus 6 over here, which is 15. And that is good to go. Plug in that 1 in the blank. And that's our answer. 2 aluminum hydroxide plus 3, I believe that's bicarbonate, makes 1 aluminum carbonate plus 6 water. Woohoo! That's 19. Okay. Sometimes the counting just gets really weird on this. I think I'm going to make like a flowchart or some kind of document you can reference for like how to get all this set up. All right. Last one. Number 20. is blank AL plus blank S8 makes blank AL2 S3. Nice. Okay. So, check what elements we got. We got ALs and we got S's. All right. Now we do our counting. For here, we only got 1 AL and we got 8 S's. Over here, we got AL2, so 2 ALs, and S3 is 3 S's. All right, everything is balanced. We're good to go. Just kidding. Yeah, hilarious joke, but ALs don't match up, S's don't match up. I think we're gonna try. Okay. Here's a fun little thing. So if we were to start with our ALs, we'd put a 2 there, because that'd be 2 times 1 gets us to 2. Right? So either way, we really end up needing to deal with the S's. Now here's the thing. We've only got AL2 S3 over here, which means we can only increase our S's by 3. So if we have 1 ALS3, that's going to give us 3 S's. If we have 2, it's going to give us 6 S's. If we have 3, that's going to give us 9 S's. In all of these cases, that does not equal 8. So that means we're going to need to change the S's on the other side. Oh, this is going to be weird. Okay. All right. So let's try bumping this up to 2. Actually, okay. Another way we could have checked this is if we put 8, which is how many we needed at the moment. Hold on. Okay. If we put 8 divided by 3 in a calculator, we'd get 2.66 repeating. Ideally, we would want this to be an even number. Like if we had 9, like if we were trying to get to 9, and we did divided by 3, because that's how many we can add by, we get 3. That would be a nice even number. We can do that. We cannot add like a fraction of a molecule. That doesn't work. So basically, what we're going to check is with our S's, for however many we add, we're going to make sure they can divide by 3 evenly. So if we bump this up to 2, that's going to give us 16 there. Now if we do the divide by 3 test, and put this in a calculator, which I would encourage you to do, use 16 divided by 3. Throw that in your calculator, see what you get. If you need some more time, pause the video. While you're doing that, I'm going to erase this. Alright, so if you put that in a calculator, you should come up with 5.33 repeating. That's not an even number. We can't do decimals of a molecule. It doesn't work that way. You either have a molecule or you don't. So we know 16 does not work, which means that 2 there does not work. Let's try bumping that up to 3. So 3 times 8 gives us 24. We know this one will be divided by 3 because we just multiplied it by 3. But if we do our 24 divided by 3 in a calculator, we'll end up with 8. What this kind of tells us, I wrote that wrong. There's supposed to be a 3 there. Excuse me. Is basically saying 8 times 3 is 24. So if we go back to this side and we're like, ooh, how many S3s do we need to get 24 S's? We know we need 8. because 8 times 3 gets us to 24. But here's the fun thing. That also changes our ALs, although that's not the end of the world. That'll change it to 8 times 2, which is 16. Which means we're going to need to change our ALs on this side. Yeah. So we need 16 total. We have AL1 over here. So how many 1s do we need to get 16 total? We need 16. Yeah. So 16 aluminum plus 3S8 gives us 8 aluminum sulfide. That is our answer. Woo! All right. Okay. Thank you for joining me. I think the rest of, like, the ones I didn't cover should be pretty straightforward to solve. I don't think there's anything that we didn't cover in here, at least for part 1. I'll probably make another video for part 2, which is page 17. But you don't need to worry about that right now. Anyways, thank you for joining. And, oh, if you have any feedback on the video, please let me know, like anything I can improve. I would really appreciate that. Right, adios.